Thanks for downloading a 3CR podcast. 3CR is an independent community radio station based in Melbourne, Australia. We need your financial support to keep going. Go to www.3cr.org.au for more information and to donate online. Now stay tuned for your 3CR podcast.
Yes, it is that time again of the week. It's time to get lost. Claire asked me where we're going to get lost.
Where are we getting lost?
Well, if I knew that, we wouldn't be lost. No, that's not true. We are actually getting lost in science, same as we do every week. Are you ready for that, Claire?
Yeah, I think I'm ready.
Excellent. My name is Chris, and this week I'm going to be answering a question that I asked myself a few weeks ago on a fine winter's day.
Oh,
Yeah,
really?
you sit around and ponder the deep questions of life.
Yeah.
The question that occurred to me was, do poisonous or venomous animals, why don't they poison themselves?
Yeah, what happens when they bite themselves?
Yeah, like if they bite their tongue or something like that.
Yeah.
Yeah.
I assume that would be pretty major selection pressure.
Thanks.
Select for animals that don't bite themselves.
Anyway, I looked it up. There's actually been some recent research in this area of various kinds of venomous or poisonous animals. And yes, I am going to cover the difference between venomous and poisonous and cover both potentialities. And yeah, the answers are quite interesting. And yes, I will explain them to you shortly.
So not as obvious as we think.
No, not as obvious as you think. No.
Wow.
But you'll go, oh yeah, that makes sense.
Well, on the show today as well, we have a special guest in the studio, Micaela Jemison from the Smithsonian, and also a lover of all things bat. She is mad for bats.
She's a bat fan?
She's a bat fan. Yep, indeed. And so Micaela is going to come in and have a chat to us about some of the weirdest and most wonderful things that she has been involved in during her time at the Smithsonian, which is the largest museum in the world. So if you can imagine, the millions and millions of specimens that they have and all the crazy stuff that their scientists are doing, she's going to bring that all into the studio. Yeah. She has some great stories about chimpanzees and naked mole rats. Yes. Oh, some
So
great
not just
stories.
bats.
Not just bats, also naked mole rats.
Where is the Smithsonian again?
Most of it is in Washington.
Most of it is in Washington?
Yes. Well, there's like
It's that
17
big.
museums or something. Okay, don't
Right.
quote me on that, but there's
So
a lot of
it's
museums.
like a cluster of museums. It's
Yeah.
not just one building.
No.
Right,
It's
I see.
it's got like whole hangars with
Spaceships.
planes and spaceships and all that sort of stuff as well. So she's going to give us the lowdown.
Cool.
Well, look forward to that. Get your sonar gear ready and let's go down the Lost in Science cave. On with the show. Okay, so Stu, I don't know about you, but I was wondering the other day, can poisonous animals poison themselves?
Funnily enough, I was wondering that the other day, and I can't remember what set
on the
me
same
off on that.
wavelength there. We're on the
You
same-
Set me off
guys
on that
have
task.
just great
Well, I thought-
daydreams, don't you?
I just thought, what if a venomous snake
Bit
was
itself.
trying to scratch its back with its teeth and accidentally slipped and bit itself in the back? Would it die?
You were also wondering about the poison dart frogs, weren't you?
I was.
I've got some happy news for you on both these counts. Well, not happy necessarily. Anyway, so look, yeah, the answer tends to be fairly complicated. But first of all, we need to address something that I think you're concerned about, Claire.
Yeah, well, I am concerned with your interchangeable use of venomous and poisonous. In my understanding, which is a taxonomist's biological understanding, venom is something that's injected into the bloodstream, so like a venomous snake. But poison is something that's ingested through the digestive tract.
Yes, that is as you say, from the taxonomist point of view, that's probably the way that people normally go with. I had someone point that to me a while back, and I was in one of those really argumentative moods, and I just went to the dictionary and said, no, you can use it either way, it's fine. But
That's interesting, because I feel like if it was a physics thing, you'd be like, no, this is the way.
I've just got to be contrary. I've got to be contrary. But also, no, I respect dictionaries. We're going to find out what the
enough. There's a
definitions
lot of
word.
work. A lot of work
I'm
goes
going to go
into
to the
them.
dictionary.
All
But no,
right,
you're right.
okay.
You're absolutely right. Yeah. So
There are things that don't purposefully poison other creatures who are poisonous when you eat them, though. That's the point.
Well,
But-
yeah, certainly like
and you know, it is nice to have a distinction and a word for both those things.
Yeah. Well, let's look at both those things separately, shall we?
Great.
So first of all, let's look at venomous animals, like snakes in particular, right? So a lot of venomous animals, the way that they work is they have some way of producing their toxins. One of the famous examples is the bombardier beetle, which ejects this caustic burning substances out of its rear end. And
great.
the way it does it uses the Araldite technique. As it has the two chemicals that it produces and it mixes them together.
Right.
And so it's only
after it's expelled from its
while
body.
it's being expelled,
Right.
like apparently a really hardened kind of tube that it goes out of. But essentially, inside its body, they're kept segregated. So that's
So
its solution.
does that mean if it came into contact with its own toxic substance, would it be harmful to it?
Probably would be harmful to it, yes. Yeah. Now, snakes, their venom glands, they're kind of adapted, modified salivary glands, and they're attached, obviously, to the fangs, the grooves in the fangs. And so it's all going on in the mouth. It's all segregated from the rest of the snake. And so that's its main thing. It's basically, it just keeps it away from everything else. It's in a special thing. It doesn't go into the rest of its body.
So it doesn't go to bite something and go, oh, damn, I swallowed it at the wrong time.
Yeah, well, the thing is, snake venom
Damn, I
is...
bit my lip.
Well, that's actually quite important. Because snake venom, it is destroyed by digestive enzymes. So people say, you could drink a cup of cobra venom and it wouldn't hurt you.
Well, hence the difference between venom and poison.
Yeah. And I think this is quite important because a snake, will kill its prey by...
And then it'll eat it.
Yeah, and then eat it. Plus, the fangs are in the mouth as well. You also don't want to be, swallowing that. But snakes also do apparently have a lot of them have some resistance to their own venom as well. Apparently, they can produce their own kind of anti-venom. They've got the antibodies to
their own venom.
Yeah.
Right.
So they've got some sort of immunity, but it's not complete. I was looking up this question, and I found a few references to people saying, there have been cases of snakes biting themselves to death. And I only found a couple of published case reports. One of them was a fairly recent one. It was published last year in the journal Toxicon, and it was reported by a couple of vets on the Gold Coast in Queensland.
Oh, great.
And
Big shout out to the Gold Coast vets.
It was fatal self-envenomation in a brown tree snake, Boiga irregularis from southeast Queensland. So this is the brown tree snake. It's not a very large snake, not very dangerous to humans. Apparently, as I put in that conclusion, dangerous to itself perhaps. So this snake had been... This particular snake it's not a happy story. This snake had been found in a mouse trap and was taken in to the wildlife kind of rescue place. So they patched it up and tried to get it better. And then they were moving it from one container to another. They kind of had its head pinned. And as they're moving it, its tail kind of whipped around. And then it saw its tail and bit onto its tail. And apparently it took them about 10 seconds to extract the tail from its mouth.
Ooh.
So there's a lot of biting going on. Apparently, the snake started to be a bit ill after about 20 minutes. It took about 12 hours to die, though. So it was not a happy snake. Yeah. And so that is like a documented example of a snake biting itself to death. They talked about the effects, because experiments have been done with his venom to see what it does, say, on mice and that sort of thing, try and work out whether the symptoms the snake showed definitely were consistent with envenomation. But one of the things that makes it interesting is because these snakes, their venom works more on reptiles and birds rather than mammals. So it's stronger on, reptiles, clearly.
Oh, so that's more of their prey than
and they do eat
rodents.
small mammals, but the larger snakes will tend to actually constrict them rather than bite them.
Right.
But for certainly like geckos and small birds and things, it'll tend to bite it. So apparently reptiles are particularly susceptible, including itself. So there's kind of an answer that they have some immunity, but they can also damage themselves. Poisonous animals, on the other hand, let's look at those. Because we did talk about the poison dart frog.
Yeah, it's the sort of famous South American...
The colourful one.
Frog that they dip their arrows in and then shoot people with them.
So it oozes a very potent poison from its skin. Apparently it doesn't make the poison itself. What it does, it kind of accumulates alkaloids from ants, mites and centipedes that it eats.
Oh, right.
Yeah.
Okay.
So it kind of sequesters the poison.
Right.
Now, there was a study that was also published last year that tried to figure out how it managed to do this and survive. Now, one of the toxins in its poison is something called epibetadine. I don't know how to pronounce that. Anyway, it binds to the receptors for the neurotransmitter acetylcholine. I love chemical names. They're so hard to say. And so it causes paralysis and various other things. Interestingly, so this acetylcholine is the neurotransmitter, obviously used in muscles and this sort of stuff. Nicotine also binds to that receptor, but this particular poison is a lot more deadly than nicotine. So nicotine, I'm not encouraging nicotine. I'm saying this one is worse than nicotine.
But is it more addictive?
It'll kill you. So anyway, it turns out they did some genetic analysis of the frogs. They found that the frogs have a mutation that causes their receptors to be slightly different, and the epibetadine, or however you pronounce it, can't bind to it anymore. The acetylcholine can still bind to it, but the toxin can't. So the frogs have basically evolved a mutation that allows them to survive this poison, which will kill basically everything else.
That's very handy.
Yeah, well, it's oozing out of its skin. It's got to have something into it. So, yeah, so there's a bit of things. So basically, evolution will find a way. It'll basically either evolve into the poisons, or you will find a way to hide it from yourself and then just try, I guess, not to bite yourself, really, if you are a venomous snake.
I'm Maggie Adair Pocock, and you're listening to Lost in Science on 3CR.
So my guest today is a lover of all things bat science and a very talented science communicator from the Smithsonian, the world's largest museum and research complex. Micaela Jemison, welcome to Lost in Science.
Thank you so much.
Now, it is the largest?
It is actually, yes, the largest museum in the whole world. So it's kind of crazy. And they have the largest bat collection in the entire world. So I was at home in this place.
So let's start with the bats. You have a love of all things bat.
I do.
How did it start? Where did it lead you to?
Well, it started... I don't want to put my age out there, but it started over a decade ago.
Yeah.
And I grew up out on a dairy farm, and I went to university and studied science, and I hadn't really come across bats at that point. But I actually started doing a little bit of work with the environmental department, so the Victorian... Oh gosh, they keep changing their name. They were DSC at the time. And I got started working on bats, and I went out with one of their scientists from the Arthur Rylah Institute, and I caught my very first bat at age 18, and that was it. I was in love because...
What sort of bat was it?
It wasn't those big flying foxes that most people see in the city. It was actually a small little microbat, and it was a lesser long-eared bat, and...
Not lesser in your heart, though.
No, greater in my heart, definitely. And the thing for me about bats really is they're so fiercely intelligent, and you can just see their little cogs in their mind as they're looking at you. When you've got one in your hands and they're looking up and they're you can see them calculating how they're going to get away. And these ones in particular, this species is one of my favourite, hands down. I've worked all around the world on bats, but this one in particular, they've got these really expressive ears.
You don't hear people describing animals as having really expressive ears that often. And if you do, it's not a compliment.
No, not generally. Sometimes it might be a backhanded insult, but with bats, it's not. So the ears on this species is, you could tell kind of where they were at by looking at them, because when you first caught them, they'd be up and frilly. There's these really long, and if you can imagine my hands going up above my head right now, there's huge ears. They look like saucers on top of their head. But once we caught them, and we'd put them in a catch bag to get them to calm down, because they're obviously a little bit excited when you first get them. These ears would curl up into the base of their head once they're cooling down, so they're a little bit cold, and when we get them back out of the bag, they've lowered their heart rate and they're trying to conserve energy. But so I always could tell how long I had until this bat was going to try and escape from me by looking at its ears. As it was starting to warm up and as it was starting to calculate what was going on, these ears would slowly unfurl. And then they'd start twitching either side. And then you could see the little eyes looking back up at you. And these ears were like, wheel, wheel, wheel around the top of its head. I'm like, you are going to try and get away any second now.
But you outsmarted the bat.
Well, not always. Sometimes they outsmarted me.
So you've worked on bats all around the world now?
Mostly in Australia and the United States. Though I did go not so much on a catching bat trip, but I have been to Transylvania.
As in where Dracula's from?
Well, you know, I went there to try and get to the bottom of this because if I had $1 for every time someone asked me about Dracula, I would be a very rich lady. Unfortunately, I am not. So
you went out with the mission knowing, okay, I'm going to put this to bed once and for all, this association with bats and Dracula.
Yes. Yes,
And
yes.
what did you find? Oh, my goodness.
You know, I dragged my husband over there on holiday because, you know, this is what you do when you're a bat scientist. Your husband asks you, where in the world would you like to go for your wedding anniversary? And I say Transylvania. So off we went. And, you know, it was fascinating because really the whole association with Dracula, and they don't really, it's not part of their culture with the Romanians. For those who may not know where Transylvania is, it is actually it's a state of Romania. But they're starting to cash in. So they're realizing us Westerners have this kind of fascination with Dracula. So you can go on Dracula tours. I did not, but I did go to the Bram Castle where Dracula is, you know, it's supposed to be what Bram Stoker actually based his character, we're going to say character on. But if you actually go back in history, it's loosely associated on a warlord of, you know, a certain period of time. And he was very frightening, but had nothing to do with drinking blood. It just seems to be one of those things that the fiction is not much to do with reality.
And the Bat Association?
Well, that's interesting because what it turns out to be is there's Romanians and Transylvanian people don't really have much adversity to bats at all. It seems to be something that us Westerners have at the time brought in from our imagination. So the vampire bat, which is actually for your listeners, comes from South America.
Yes, of course.
Yeah, there's 3 species of vampire bat. One species actually focuses purely on birds, only drinks blood from birds. Mm-hmm. And then there's another species that focuses more on mammals. But at the time when the book was written, the knowledge about vampire bats and everything had come back through to Europe. But Dracula and, you know, vampires that it was based on were around in our kind of minds well before the vampire bat. So
if Dracula's going to live anywhere, it would be in South America,
exactly,
where the vampire bats actually live.
Yeah. Yep. But no Dracula over there. That's only in Europe. So go figure that one.
Now, Micaela, you work at the Smithsonian.
Yes.
What do you do there in the world's largest museum?
You know what? I have the best job. Hands down. I have the best job there because as a science communicator, so I get to go in and just play. And I just get to go to visit all the different scientists and all the amazing research they're doing. I get to go in when it's the most fun, go to witness what they're doing and help them write up or communicate what they're doing to the rest of the world. And then once the boring data has to be crunched, I leave. So I've had some really great experiences over there. And for those who are not familiar with the Smithsonian in the United States, it is one of these places that has a huge amount of research and amazing artifacts and collections behind the scenes. So there's it's a series of 19 museums and research institutes.
Wow, 19.
19.
Scattered all around North America or some?
They're all based in Washington, D.C. Some of them are a little bit further out in some of the regional areas around the city, but they're all based in the nation's capital, and it also includes the Smithsonian National Zoo. So I've got to do a couple of really interesting things with the zoo as well. One of which I recently got to hold a naked mole rat.
You got to hold it in your hand.
Yeah, I did.
Now, for our listeners at home who've never seen a naked mole rat, it's pretty much those 3 descriptive words are very appropriate for it. Mm. It looks like...
I don't know if we can say this on radio, but basically it's a penis with teeth. They do look like that. And, you know, the interesting thing about their teeth is they're outside their mouth. So they've got these giant, you know, rodent-like teeth, and they're actually used mainly for digging. So they're crunching through the soil. They spend pretty much all of their lives underground, and they're from Africa. And they eat mostly tubers and things like, you know, underground roots and things like that. But the really interesting thing is they have a queen. They're a society like bees. So they have
a social...
Yeah, it's
society.
Social. So it's called eusocial, and what it means is that the queen is the only one that breeds. So she's the mother to all of the little mole rats in this, and it can be up to hundreds of mole rats in a colony. And they're one of these amazing animals. One single queen in her lifetime, they're very long-lived, they can live over 30 years, can have
That's quite old.
It's very old.
Very old for
She can have
rat.
up to 900 babies in her lifetime.
Whoa. She starts early.
She starts early, and in one litter, she can have up to 30. It's crazy.
My goodness.
Yeah. So,
And how does one become queen?
well, it's kind of like Survivor. It's not actually like in
It's
bees.
not passed down.
No,
or-
it's not in like bees where you're born to be queen. It's really any female can become a queen. She just has to kill the other queen.
Right, so it's more of a Game of Thrones type affair.
It is really the Game of Thrones. You can actually watch these animals online now. The Smithsonian National Zoo just have got a new exhibit, and they're including webcams that will run 24/7, so you can see what's going on in the tunnel world of Game of Thrones.
So people can just Google Smithsonian naked mole rat.
Yep,
webcam.
and you'll find it.
Oh, that is excellent. You've got my evenings for the rest of the week lined up. Oh my goodness. So, I mean, that is an incredible story. You must have come upon some very interesting stories with your time at the Smithsonian. Any other favourites?
Oh my goodness, where do I start? You know what? The best thing is really getting to visit behind the scenes. So what you see in the public when you go to these museums, you only see about 1% of what is actually there. For example, the Natural History Museum has its own storage facility out further out in Maryland, and it's about the size of 6 airplane hangars. It's huge. And out there, they've got everything. If you could imagine huge tanks about the size of an SUV, and in those tanks, you will find whole hippopotamuses. You will find, I've seen giant squid with, in these long glass tanks about the size of a bus, huge. And one of the best things I got to be involved in was when they were doing some CT scanning of some of their mountain gorilla specimens. So, and you can go online to see this. I've got a video, and I'll make sure that we can see the link.
That'd be great.
Yeah. So basically, I was out there when they were pulling these great big vats in and using a crane of some sort to pull out this huge male mountain gorilla, and it must have weighed a ton. Seriously, but.
Collected a very long time ago. Some of these specimens have been in the collection for well over 40 and 50 years. And what they were doing was really neat, because they were finding, we had to find a CT scanner big enough, those big white machines you see in the hospital, and we were putting them through so that the scientists from all around the world, scientists from all around the world come to the Smithsonian to try and study these specimens. But it's a long way to travel, and when you're trying to taking them in and out and looking at them can degrade them. So one of the things they're doing is providing these scans and providing them online, so scientists can do their research online without having to actually physically be there. So a scientist who might be interested in what is exactly inside a mountain gorilla can just go online and be like, okay, this is it.
Yep.
This is the CT scan of the whole
Here's the
mountain
data.
gorilla. This is what is inside.
Yeah.
Wow.
Yeah, and they're doing more and more of this. But one of the interesting things of it was this gorilla was so big, we were really struggling to put it through the scanner. So you will see on the video, there's a whole bunch of us standing around trying to push it through.
Oh my goodness.
So, but yeah, that was amazing. And like they're from actual animal specimens right through to some really cool anthropological stuff. There's one of my favorite memories was one of the curators showing me this beautiful, huge cloak. And it was made out of these tiny, tiny little feathers. And it was from Hawaii. And it was from one of the original kind of native peoples of Hawaii. And this cloak was brilliant yellow and red feathers, and they were just really, really tiny, and they were from a bird that was extinct. 2 species of birds that are now extinct. And when this cloak used to be worn by the chief of this tribe. You know, this would be handed down generation through generation. When it finally came into the collection and they were looking at it, they estimated that probably 1,000 birds or more were used to create it. So it's one of those things where you've got these artifacts out there that otherwise might be lost to, you know, what their meaning was in time. And, you know, there's so much you can do with these collections to understand not only the cultural significance, but maybe what the biological significance was as well. So sad but beautiful.
So, Micaela, has there been, I have to ask, has there been a lot of crossover between your interest in bats and your work at the Smithsonian? I know you said they have a very big bat collection.
I know. I was the biggest bat nerd, I gotta say. So one of my favourite things to do in my lunchtime was to take my little keys and go and play in the bat collection and just open up random drawers and see what I could find. So, yes, I think in my time, the Smithsonian has never had as many bat stories as I have produced. One of my favourite things has been working with colleagues from around the world, as bats are one of those really interesting groups where we're always finding new species. They're actually the second largest group of mammals in the world. And with over 1,300 species, we're closing in on 1,400 right now. And so one of the great things is not only as we're finding new species and what goes into that, but also understanding the real diversity in terms of what these animals do. You know, we all know bats eat insects, yes, and we're lucky here in Australia, I think so anyway, that we have flying foxes that are very much fruit eaters. But we've got so much more out there. We have got bats that eat fish. We have got bats that eat mice and other bats. And you name it, there's a bat that does it.
Bats that eat blood.
Yes, that is one of the most famous ones. Yes, that is true. But I actually am, one of the ones that I'm more excited about is a bat that specializes on spiders. And it's actually an Australian species. And I have seen video. I have not been as lucky to see it in the wild, but I've seen video of this where this bat is such an agile flyer. It can fly up to a spider web and pick the spider out of the web and not actually break the web and then fly off.
Wow, so it doesn't even get tangled up in the web like the rest of us would if whenever we get close to the spider web.
No.
Wow.
Yeah, it's pretty cool.
Where do you find them?
Around New South Wales, I believe.
Oh, goodness. Yeah. So there is a lot of crossover in your roles.
Yes.
You do get the opportunity to indulge in your bat nerdery.
I have, yes. So at the Smithsonian, I've done a lot of that. And I have worked for places like Bat Conservation International as well, where I talked bats 24/7.
Well, Micaela, I could talk bats 24/7 with you all day. These are the greatest stories ever. Micaela Jemison, thank you so much for coming on Lost in Science today. And please, anytime you have any more stories, come back and tell us.
Oh, I'll be back. Don't worry.
And that's it for another episode of Lost in Science. Lost in Science is, of course, recorded in the studios of 3CR in Melbourne, and it airs across Australia on the Community Radio Network with the support of the Community Broadcasting Foundation. We would love you to get in touch with us. Please send us an email at lostinsci@gmail.com, or you can find us on Facebook, you can find us on Twitter. You can find us on your local podcast app, whether it's iTunes or Google, whatever. If you can, give us a good rating so you can help other people find us, or you can just listen to us on the radio. And same time next week, Claire, Stu and Chris will get
Lost in Science!
Thanks for listening to a 3CR podcast. 3CR is an independent community radio station based in Melbourne, Australia. We need your financial support to keep going. Go to www.3cr.org.au for more information and to donate online.